Since there are so many ways of coming to the conclusion of a power series for a given function f, it is a logical question to ask if, the power series you come to the conclusion of is truly unique. In other words, is it possible to find a different power series function with a different technique? And the answer is no. And that's kind of the whole point of this uniqueness of power series theorem. So to start off this theorem, we have two series. First, let's let n from 0 to infinity times Cn times x minus a to the n. And we also have n starting at 0 to infinity times x minus a to the n be two convergent power series such that the series as n go to infinity, starting at 0, such that they equal each other. For all x in an open interval containing a. Then Cn has to equal Dn. How did a power series representation for the function f of x about x equals c exists the Taylor series for f of x about x equals c is f of x as n goes to infinity from 0 over the function c n factorial over x minus c to the n, which equals fc plus f derivative c plus f derivative plus f derivative and so on and so forth. For this problem, we will be writing down the Taylor series of the function f of x equals 3 over the factorial of 2021 times 1 over 1 plus x squared. And as we recall from the definition of a Taylor series function centered at c, the very first thing that we need to do is we need to kind of figure out the first few derivatives and evaluations of this function to understand what we're working with. So just to kind of get a sense of what's going on, at the 0th point, this is just 3 over this is just our function definition. So now we need to find the derivative of x, and I already did this calculation, and it is n equals 1. So we know that we have negative 1 to the n, first of all, in the numerator. We also have 3, 6, and 18. So 3 times n here is 0. 3 times n plus 1 is 3. 3 times n plus 2 here is 6. So we know that we have to multiply this by 3 times n plus 1. So that's our numerator. As you can see here with n equals 0, we have 1 times 3 times 1, which is 3. With 1, we have negative 1 times 3 times 2, which is negative 6, so on and so forth. Now I need to think about our denominator. We see that our factorial here is constant. And then we also see here that we have 1 plus x growing by 1 every time starting at 2. So n plus 2. And now we need to evaluate this as well, which basically just means we need to plug in 2 for x. So we get is negative 1 to the n, this is just from here, times 3 times n plus 1 over, remember we're dividing by n factorial, times 2021 factorial, times, times what do we have here? Yeah, we say 3 to the n plus 2. And then here I forgot to include x minus 2 to the n, x minus 2 to the n. And now we need to find an expression of f2021 centered to 2 using this Taylor series, and Q1 we plug into this Taylor series, not the original power series function. So all we do here is using this, negative 1 to the 2021 times 3 to the 2022 over 2021 times 2021 factorial on both times 3 to the 2023 is x minus 2 to the 2021. So it's as simple as just plugging in those equations. So this comes out to negative 1 times 6066 over 2021 factorial squared times 3 to the 2023 times x minus 2, 2021, which equals negative 6066 times x minus 2, 2021 over 2021 factorial squared times 3 to the 2023.